Hello everyone, welcome back to the channel Learn Live and Explore with Shanmugh. In the previous video, we have discussed about the MySQL and the MySQL command languages. In this video, we are discussing about the important topic in the database management system, which is the normalization and the normal forms in DBMS. Already discussed that the databases are used to store and retrieve the information. So there might be a chance sometimes that the data present in a table will be repetitive, which means that the data present in a table will be repeated multiple times. Suppose for example, if the data contains a name Suresh, so there is so many persons with that name Suresh. So to eliminate that data redundancy in the database, this normalization technique is developed. Normalization technique will follow some stricter rules and guidelines. There are four types. The first one is the 1NF, which stands for first normal form. The second one is the 2NF, which stands for second normal form. And the third one is the 3NF, which means third normal form. And the final one is the BCNF, boys code normal form. So these are the four set of rules and guidelines that the normalization will follow in order to ensure the data redundancy and to maintain the data consistency and integrity. So let's discuss each one in detail. So let's discuss the first one in the normal form, which is the 1NF first normal form. So the rules in the first normal form is each column should maintain atomicity, which means each column should maintain atomicity. That means the values in each column are indivisible, which means we cannot divide the values present in each column. And the second one is it should be forms a repeated groups. It should not form any repeated groups. So these are the rules present in the 1NF, which means the first one is the it should maintain atomicity, which means the values are indivisible. Suppose consider a table. Suppose this is the student table. In the student table, we have columns like student ID, student name, and subject. The student is enrolled. So the first student ID is 1 and the second one is the 2. The first student name is Ravi and the second student name is Anjali. And the subjects enrolled by Ravi is maths and science. Subjects enrolled by Anjali is English and history. In this table, observe the table. The first column maintains atomicity, which means it presents a single value. The second column also maintains atomicity, which means this column contains single values, Ravi and Anjali. But the third column violates the 1NF, which means it contains multiple values instead of containing atomic values, which means single values. It contains maths and science, and this one contains English and history. So let's solve this. So in the previously discussed table, which means the student table, it violates the first normal form. So why? Because in the subject column, it does not maintain atomic values. Instead of that, in the subject column contains multiple values. So this table is the solution that cannot violate the first normal form. Why means here each column is maintaining atomic values. So what we have done is the previous table will be divided into this like this. The first student ID is Ravi and the second student ID is Anjali. So we have the subject column violates the first normal form in the previous table. So what we have done is we have divided the subjects into divisible parts, which means separate groups. The student ID is 1 and Ravi the name. So Ravi is enrolled in maths. Next, the student ID is 1 and name is Ravi. Ravi is also enrolled in science. We have divided these subjects into different columns or different rows. So like that, Anjali, we have also divided this so that this table will maintain atomic values in each column. As you see here, here it maintains 1 atomic value and here it also maintains 1 and here we have 2 and here we have 2. So as you observe this table, there are no values which are more than 2 in each of the column. Here maths is the only atomic value present and here science is the only atomic value present and here English is the only atomic value present and here history is the only atomic value present. So which means it follows the first normal form, which means it maintains atomic values in each and every column. So this is the solution for the previous table so that we can follow the first normal form. Normal forms, which is the 2NF, second normal form. So there are two rules in the second normal form. The first one is it must follows the first normal form, which means it must obeys the first normal form. And the second one is the it should remove the partial dependencies, which means each non-key column should depend on the whole primary key, not just be a part of one. So we have a table here. Here the columns present is student ID, course ID, student name and course name. Here student ID is the primary key column for the student name. Course ID is the primary key column for the course name. So here in this table we have two primary keys. One is the student ID and second one is the course ID. And we have two non-key columns, which is the student name and the course name. We already discussed that in 2NF it should remove the partial dependencies, which means these two non-key columns should depend on both these primary keys instead of being a part of one primary key. So the solution for the previous table is we can divide the table into three parts. In normalization technique, we can divide the tables into smaller tables. So we divided the previous table into these three tables. The first table contains two columns, which is the student ID and student name, and the second table contains the two columns, which is the course ID and course name. The third table contains two columns, student ID and the course ID. So the student ID here in the first table is 1, which means Ravi. Here in this third table the student ID is 1 and the student name is Ravi, and the course in the third table enrolled by 1 is 101, which means it related to the second table, and it related to the second table. The course ID 101 is the course name maths, so Ravi is enrolled in the subject maths. So here in the first table the student ID is second student ID is 2 and her name is Anjali, and here in the third table the student ID is 2 and with the student ID 2 the course ID, the student is enrolled with course ID 101. So this third table is related to the second one, which means the course 101 ID is enrolled with maths. So Anjali is also enrolled in mathematics. So in this way we can remove the partial dependencies, which means the two non-key columns here is the student name and the course name. These both is should be part of these two primary keys instead of part of being one. The third one in the normal forms is the 3NF, which means the third normal form. Here that there are two rules. The first one is it must follows the 2NF, second normal form, which means it must follows the 1NF also. And the second one is the remove transitive dependencies. Transitive dependencies means one attribute depends on another attribute through a third attribute. Here let's discuss with this table. Here the table contains four columns. The first column is the student ID, second column is the student name, third column is the department, fourth one is the HOD. Here the HOD column is depends on the department column but not with the student ID directly. So this is a transitive dependency that violates the 3NF, third normal form. So let's solve this. So the solution for the table in order to follow the third normal form is this. So we have divided the table into two tables. Here the first table contains three columns. The first column is student ID, second one is student name, and the third one is the department name. And the second table contains two columns, department and HOD. Here in the second table the HOD directly depends upon the department column instead of the student ID. But in this first table the department depends on the student ID. When the department HOD is Dr. Rao, the Dr. Rao is associated with department CSC. Here in the first table, the department CSC and the student ID enrolled is 1, which means Ravi. Ravi belongs to CSC and his HOD is Dr. Rao. So in this way, we can eliminate the transitive dependencies in order to follow the third normal form. Because the final one in the normal form, which is the BCNF, Boy's Code normal form. So there are two rules in this Boy's Code normal form. The first one is it must follows the 3NF, third normal form, and the second one is every determinant must be a candidate key. Here we have a table. In this table we have three columns: course, professor, and room. Here the course and the professor both are not candidate keys, so it violates the BCNF, Boy's Code normal form. So let's solve this. The solution for the table is this. We have divided the table into two tables. The first table contains two columns, which is the course and the professor, and the second one contains two columns, which is the professor and the room. Here in this BCNF, every candidate key, which means every determinant must be a candidate key. So in this, the course instructor, which means the professor, is the candidate key. So the candidate key is nothing but it should uniquely identifies the data present in a table. It should uniquely identify the data present in a table. And here the course DBMS is uniquely identifying that the professor of the DBMS is Professor Smith, and here the professor of OS is John. So the professor is a candidate key which uniquely identifies the course DBMS and OS. Similarly, the Professor Smith belongs to room number 101, which means the Professor Smith is a candidate key. It uniquely identifies that he belongs to room 101, and here John is the candidate key. Here this John candidate key identifies that the John belongs to room number 102. So this is how every determinant must be a candidate key in the BCNF, Boy Scout normal form. So these all are about the normal forms present in the DBMS and the normalization technique. So with this I am going to close the video. So thank you for watching.
If you enjoy the content I create and want to see more, the best way to support me is by hitting that like button. It really helps me reach more people and grow our community. And if you want to stay updated with all my latest videos, make sure to subscribe and turn on the bell icon. That way, you won't miss a single upload. Your support means everything, and together we can make this channel even better. So like, subscribe, and let's keep this journey going.